All right, this video is going to go over exponential functions on how to solve. Just a quick reminder for those, for any real number x, an exponential function is a function with the form of f of x equals b to the x. And remember, b is any positive real number such that b does not equal to 1. The objective here for today, though, is for us to solve using the same bases, all right, like bases. So the rule says is if we have b to the m equals b to the n, then m must equal n, meaning our bases drop away and we're able to solve for the function. So first things first, we rewrite the equation in the form of b to the n equals b to the n. Okay, that means if our function does not start with the same two bases, we must try to rewrite it. Okay, second step is to set m equal to m. The third step is to solve for the variable. So in our very first equation, I gave us something very simple to do. And I said we have 4 to the x plus 5 equals 4 to the 7th. So since they have the same base, meaning our bases are both of 4, then the bases just simply drop away. And now I'm left with x plus 5 equals to 7. Well, I take x plus 5 equals to 7, and then I solve for x. Subtract 5 from both sides, and x equals to 2. Okay? My second equation or example that I have is a little bit different. I have 5 to the 3x minus 6 equals to 125. So technically right now my base is 125 to the first power. But we can make a change of that, right? We can say what number is perfectly squared, cubed, or what number has a base of 5 that would give me 125? Well, that would be 3. So I have 5x to the 3x minus, excuse me. So all right, today's video is going to be on exponential functions, specifically on how to solve using the same basis. So just a quick reminder, for any real number x, an exponential function is a function with the form of f of x equals b to the x, where b is any positive real number. So our first objective, like I said, is we are going to use the same basis to solve the exponential equations. So if I have b to the m equals b to the n, then that simply means we drop the bases and now we set the two exponents equal to each other and we'll have m equal to n, right? So what are our steps? Our steps are fairly simple. Number one, we rewrite the equation in the form of b to the m equals b to the n. That's step one. Then again, step two, set those two exponents equal to each other, and then we solve for the variable. So in our first example we have here, we have 4 to the x plus 5 equals 4 to the 7th, correct? So now, like I said, if our bases are the same, then our exponents or our bases simply drop away and our exponents are set equal to each other. So this will give us x plus 5 equals to 7. And then we can simply solve for the equation. So now we subtract 5 from both sides, and now x equals to 2. So not everything will come out as simply as we would want them. So yes, we have 5 to the 3x minus 6 equals to 125.
Yes.
That clearly shows us that we do not have the same base. In order for us to start changing a base, we have to think about our numbers. 125. Could that have a base of 5 and an exponent? Well, it could. 125 is technically 5 to the third power. So let's rewrite the problem. This is 5 to the 3x minus 6 equals 5 to the third power. Now that our bases are the same, we simply drop the the base and we rewrite the exponents as 3x minus 6 equals to 3. So 3x minus 6 equals to 3. Now we can solve. Add the 6 to both sides, and 3x equals to 9. Divide both sides by 3, and x equals simply just 3. Now, again, the best way we can also check ourselves, right? Check, is to plug it back in. But for the shortness of our time on the video, I'm not going to plug these back in. Okay? Now, the next question, example number 3. We have 8 to the 4th, 8 to the x plus 2 equals 4 to the x minus 3. So, could we change 8 to a base of 4?
Yes. No.
No, we surely can't, right? So, we have to change both the bases here, right? Both 8 and 4 are commonly even numbers. So, could we change those bases to a base of 2 perhaps?
Yes.
Yes, we could. So 8 is technically 2 cubed times x plus 2, right? And 4 is technically in a base of 2, but it's 2 squared. So that'd be 2 squared times x minus 3. Okay, so again, you see that you have to change sometimes both bases in order to receive your same answer. So now, if I have the same base of 2, right, these 2's drop away because they are the base. And now I am left with 3 times x plus 2 equals to 2 times x minus 3. Now we must go ahead and distribute. So 3 times x gives me 3x. 3 times 2 gives me a plus 6 equals to 2 times x, which gives me 2x, and 2 times negative 3 gives me a minus 6. Since we're solving for the equation, I would subtract the 2x from both sides. Okay, I just like my x's on the left-hand side, and that leaves me with 1x equals to, 1x plus 6 equals to negative 6. Subtract the 6 from both sides, and then x equals to negative 12. Okay, and now we've solved the problem. Now, if you have things in the base of e, right? E, the natural base. We talked about the natural base. The natural base is a 2.72 some very long number, right? So if we do things in the natural base, the same rules apply. Are the bases the same? Sure, they're the same. So that means we would drop the bases and we would rewrite it as just now x plus 3 equals to x minus 1. So now we need to solve for x. So we would subtract the x from both sides. Uh-oh, what has happened here? Right? If I subtract the x from both sides, 3 equals to negative 1. Is that possible? No, not possible. So in this case, we will have a no solution. Okay? Now, very similar to what we were just doing, I wanted to throw the monkey wrench in there. We have e to the 3x times e to the 5th equals e to the 17th, correct?
Correct.
So now we need to use our exponent rules. Do you remember your exponent rules? If you have something that has the same base and you are multiplying, then you would add your exponents. So in this case, we have e to the 3x times e to the 5th. This means that we need to add the exponents and rewrite it as e to the 3x plus 5 equals e to the 17. Now that we have the same base, right, the bases will go away And we can rewrite this as 3x plus 5 equals to 17. Don't have enough space. So 3x plus 5 equals to 17. I'm going to subtract the 5 from both sides, and 3x will equal to 12. Divide both sides by 3, and then x will simply equal to 4. And again, the best way to do something is to check yourself by plugging it back in, okay, to the original equation. And we'll come back for another video for objective number 2, which is on compound interest formulas in just one moment. Thank you.